I want to talk a little bit about some of the sciences that are involved. So one of them obviously is neuroscience, and neuroscience, tells us things, some basic things like things that support hippocampal functioning that can lead to better learning, such as sleep or exercise, time, and also actually stress. Neurotransmitters released during and after stressful events are actually major modulators of human learning and memory processes. So knowing how stress affects learning and being able to incorporate that into the design of your environment, because there are places where stress is really good and there are places where stress actually really harms learning. So that's some of the things we can learn from the neurosciences and feed back into the neurosciences. Also, we know that from the neurosciences that memory is associative, and that when you learn something, you essentially need to associate that information with prior or old information. And our brains take advantage of our existing neural networks that are built on our previous experiences and learning. And so the brain's not building from scratch every time we learn something new. The way that we actually support someone to learn something is to scaffold their building synapses within and across their existing synaptic network. We never remove old information. All we do is build these new synaptic networks that we then strengthen by practicing over and over and over again. So you can't really change a habit or a behavior without essentially repeated practice of strengthening that neural pathway. Oh, I should say there are obviously exceptions to that. Some of my colleagues at Stanford are doing research in neurobiology, mostly working with mice right now, where they're showing that you can actually interrupt neural pathways and reset new learning pathways sort of chemically or with light. But we're not doing that with humans yet. So for right now, really the only way we can support humans from a neurological perspective is not directly interfering with their neural networks, but understanding how those neural networks are built and strengthening practices that help them strengthen those. So there's also cognitive science, which would also reinforce some of the ideas that we see from neuroscience, such that new knowledge is built from prior knowledge. But there's all kinds of stuff, all kinds of experiments that are being done in cognitive psychology that should be informing our learning practice, but it doesn't get translated that well into hands of people that can actually put it into practice to learn something. But there are some counterintuitive findings, and I'll just share like one of them. So, for example, if you were teaching someone something complex, is it better to give them 2 examples of this thing, or an example and then explain what the example is showing? Like if I'm trying to, so I don't know if we want to do a little vote on that or think about that for a moment. What's better? If you're teaching someone something, what do you usually do? Do you just give them 2 examples, 2 different cases, or do you give them an example and then explain to them what they should notice in that example? Okay, great. So I know our usual practice is 1 example and explanation. But actually, research shows us that 2 examples actually works better. If you give people 2 examples and then you actually facilitate their trying to extract a principle out of that, rather than giving them the principle directly yourself, that will facilitate learning better. What actually works even better is giving them 2 examples, having them struggle with what do those 2 examples show them, and then giving them the example. And this makes sense when you get what I was just saying about that all new knowledge is built on prior knowledge. What's happening in this case is as they're struggling with the 2 examples, they are struggling with what are the deep structure issues in those examples that make them similar. So that when you explain it to them, they've built a cognitive structure that explanation now makes sense. This also is kind of at the root of some of Dan Schwartz's work on invention as preparation for future learning, where if you give students a problem to struggle with and have them try and invent a solution before your lecture explaining the solution, they will be able to apply that much better further on down the road. That's just, I mean, and there's a ton of these things that we're learning in cognitive science that could help inform the design of learning environments. Then there's also social psychology. And I mentioned before that that identity is incredibly important. The diversity of identity is incredibly important when you're thinking about learning environments. And this builds on the work of Claude Steele and others in the area of stereotype threat. And we have pretty compelling evidence that if a learner is in a situation where they believe that some aspect of their identity is threatened, they will perform substantially and significantly, statistically significantly worse than in a context where their identity is not threatened. And part of that is because they're spending a lot of their cognitive resources managing the environment and managing the threat. So it's really important to pay attention to the cues in your environment that either explicitly or very unintentionally signal to a learner that their identity is threatened in that context. And I'll be happy to talk more about that too. Then there's the last one is measurement science. When I'm talking about collecting evidence from the learner's interaction and modeling that, of course, that gets squarely into measurement science. Sort of what is it that you're collecting? How do you score it? What inferences are you making from that? And so on. And then, of course, the last science that I'll talk about is machine learning and data science, which many people used to historically not think of as part of the learning sciences, but is an incredibly important part of the learning sciences now. And a lot of the approaches that people are taking, including the things that I've been describing, where you take data from learners' interactions in the environment and you model that data to make estimates about the learner's current knowledge state in order to give that information to the learner or to the instructor or to the course designer. All of those underlying models are ML models and data science models. And the important thing for higher education is that those models are, and how you model and what features you select, those are not neutral. And there are two risks here. Yep. So I love this that Chris Hoffman wrote. I'm sure you're familiar with the concerns about diversity, the ethics. Yes, it's exactly where I was going next. So there are two different ways that these models could essentially tool in the systemic bias that already exists in our system. One of the ways that happens is the data. These models are often trained on data, on large data sets. And so if you're using an unsupervised method of training your model, where you're just giving your model thousands and thousands and thousands of pieces of data and asking it to optimize for achieving an outcome, then you have to make sure that the data that you are giving it is not already biased, because the bias is in the data, which I think is actually one of the real benefits of using these models, because we can feed the data into the model. We can see the outcomes that the model produces, and that will expose to us the systemic bias that is in the data because it's been in our system all along. So if you make sure that you're inspecting how the model is performing and not just blindly taking the outcome as ground truth, then this provides a real opportunity of revealing systemic bias that's already in the system. Then you can actually tune the algorithm to mitigate for that systemic bias. And there are some of my colleagues at Stanford, Emma Brunskill in particular, and Chris Peach are looking at ways of actually having models detect systemic bias and then tune the models automatically to compensate for that bias. And then the piece that Nancy added is also really important. When you're using especially rules-based algorithms, or when people are selecting, when humans are selecting the features to include, it's really important to have diverse teams, diverse perspectives of people that can be making those selections from different perspectives. Absolutely. Although I would also say that just having someone who has demographic diversity doesn't necessarily mean that they're going to be able to hold the stake for that population that has that demographic diversity. I mean, I can speak to that from my own example. When I was at Stanford, I had created a course on data analysis and statistics that was an open and free course on the Stanford online learning platform. And one of my graduate students who studies inclusion and diversity and stereotype threat was looking at the statistics from my course and said, Candace, your course has about 75% men enrolled and about 25% women. And I thought, that's kind of, I wonder why. And he said, well, you might look at every course at Stanford has an image. That's the introductory image that you click on, the little tile. And the little image that I had selected said sort of data analysis and statistics, and it was in that sort of computerish kind of font with like nice sigmoid curves and stuff like that on it to sort of, excited me, the picture. And he said, well, that picture, whether you know it or not, may be signaling to people that they don't belong here. So why don't we do an experiment? Let's do two things. Let's change the image, and so that people get a visual signal, women get a visual signal that they belong in this course. And then let's also add an inclusion statement, because at the beginning of the description of every course, it just says this course is about, and then you say what the course is about. And we just changed that statement to say this intentionally inclusively designed course is about, and then the rest of it was the same, about data analysis and interpretation. And then we changed the image from the image I had chosen to an image of a woman with her back to the camera, with her little laptop open, with a histogram or some statistical graph on her computer screen. And her feet were up, she looked relaxed. And just that change changed the enrollment in the course by 25%, changed the gender balance of the enrollment. So just those, and the reason why I bring that up, in addition to being socially self-critical, is to say that I'm a woman, I'm a feminist, I pay attention to this stuff, and even still, I didn't see it. But the data showed me that there's something that I was not paying attention to. And I think that's because we were all raised in the same culture. And so we're breathing in the systemic bias of the culture all the time. And it takes very conscious awareness to choose to see it differently. So anyway, there's probably a long tangent to respond to Nancy's comment. So yes, but it's very important for people to be able to see themselves in the learning experience. Okay, so I was going to talk about an experiment that we did where we actually did have an algorithm make the selection. So this is the development process we currently use, that we have the designer create the educational activities, the learning tasks, and so on. The learners then engage with those activities. The learner traces get sent to our knowledge modeling algorithms. The skill model in the learner model then that information gets given to an instructor or to the designer, who then makes changes, and then that's a positive feedback loop. And we did an experiment where we we took out the instructor and learning designer and put in a reinforcement learning agent, which is an ML algorithm, that essentially, it didn't design the activities, but it observed learners interacting with the activities and then decided in which sequence to give the learners the activities. So we had 3 conditions to this experiment. We had the instructor designed condition, which was a set of activities that the instructor said the learner should do it in this order to maximize learning outcome. And then we had a condition that was an open navigation condition, the same set of activities, but the learner was told these are your outcomes. You choose what to work on next and when you're ready to take the post-test. And then we had this reinforcement learning agent condition, where we train the reinforcement learning agent to select and sequence the activity. It's funny that someone just mentioned Acrobatic in the chat, because Acrobatic was actually a company that was spun out of Carnegie Mellon, and it was spun out from the project that I started at Carnegie Mellon called the Open Learning Initiative. And then the then provost decided there's money in them their hills. So I was giving it all away free, working with tons of institutions of higher education and giving it all away free. And the provost said, oh, we could make a company out of this. So let's spin out this company. And he did that when I went to Stanford. So I couldn't stop it.
Cool features that like ingest content and create assessments. Yeah, similar kind of what you're describing.
Yes, yes. Right. Yes, yeah. Yes. And so those mechanisms are mechanisms that are the Open Learning Initiative that's still at Carnegie Mellon now can also is still building those same kinds of mechanisms. So if you're looking for an open educational resource project to do this kind of thing, I would point people there. But yeah.
Can you say that again one more time? Which initiative?
Sure. It's called the Open Learning Initiative.
Great, thank you.
And it's part of the Simon Initiative at Carnegie Mellon University. And I started that project in 2002 at Carnegie Mellon, and then I was at Carnegie Mellon for 12 years, and then got recruited to Stanford, and so then started a sister project using the Open edX platform at Stanford. But I've still kept in very close connection with the project at Carnegie Mellon. So yeah, they're still doing really interesting work there. So in any case, the results of that research, and we did this research at Amazon, was that in fact the reinforcement learning algorithm did do better at maximizing learning gain as measured on pretest to post-test than either of the other 2 conditions. And the students in the instructor-led condition didn't persist as long, and the students in the self-navigation condition didn't achieve as high a learning gain. Sure, I'll send you, so someone asked for the Open Learning Initiative webpage, I will certainly send that. It's just, if you search OLI, or maybe it's called the Simon Initiative now at Carnegie Mellon, but if you search the Open Learning Initiative at Carnegie Mellon, you'll find it easily. Okay, great. So shoot, I wanted to, I'm gonna stop there. I was gonna go into why do we need all of this science, because learning is complex, but I think all of you are, yes, so the question is there a publication presentations about this reinforcement learning experiment? Yes, it was presented at CHI, which is CHI, which is a Association for Computing Machinery International Conference that sort of sits at that is human-computer interaction conference. But I'll send the citation to the paper as well, and you can read all the details in it. But what I don't want people to take away from that is that what I'm saying is it's better to let an algorithm select and sequence learning. Don't take that away as the message. Take that away as there are some tasks that we can train an algorithm to do better But there are many, many, many tasks which we really need human instructors and human learners to be actively participating in. And I think the goal is to figure out what parts of the decision making is best done by a machine to help out. I mean, you can think about these systems not as replacements, but yes, someone did find the paper, but but as a really good teaching assistant. I mean, along with your other teaching assistants. So it's very much the focus is on augmenting learning, not replacing instructors. Because in our current, what I think instructors in higher education, faculty in higher education, and researchers need are better tools. We're being asked to do something that is undoable given our current tool set, which is to educate a huge number of learners that have a great diversity in all of the dimensions we've discussed, and try and get everybody to the same level of learning and have diverse goals. Try and help all of those people get from where they're starting from to where they're trying to get to. We just can't do it with the current tool set we have. And the information technology, if we design it right, does support us to be able to do that undoable task in a way that is doable. So I'm going to just stop there and just see. I will stop my. Oh no, I'm going to actually end with my. This is my thing about complexity of learning, but I'm gonna actually end with my two quotes, which is one from Herb Simon, who was also at Carnegie Mellon, and he said this in 1991. Improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity. And then the second quote is from William Baumol, who said he was an economist in 1967. He was very prescient. He said, without a complete revolution in our approach to teaching, we cannot go beyond our current levels of productivity. And when I used to give this presentation, when I was still back in higher education, my message was such a revolution is possible. But I'm changing that message because I can see that it's not that it's possible, that revolution is happening. And these information technologies are going to fundamentally shift the way we do higher education. But my question is the same, who's gonna lead it? So I will leave that there and then see if there are any questions or comments.
Candace, people are asking if they can follow up with you.
Oh, absolutely. Yes, and yes, we can get a copy of the presentation, and yes, I'm more than happy. I mean, I know I threw out a lot of ideas, and we didn't really deep dive into any of them, but this is my passion, this is my mission, so I'm more than happy to talk with any of you. So I'll just put my email address in the so let me do to everyone.
I just want to say thank you because this was super interesting. I really, really enjoyed your presentation.
Thank you.
Absolutely. This has been amazing. Thank you so much, Candace.
Oh, you're welcome. Does anyone have any questions, or does anyone want to take me on? I love, you know, I'm an academic at heart. I love challenging questions and things like that.
I have a curiosity. So when we're presenting things like this to learners and saying, okay, if you want to do better at this objective, here's what you can do. Are there ways that we can avoid basically creating like a negative self-fulfilling prophecy where we tell them, hey, it looks like you're struggling with this concept, but can instead frame it in a way to encourage them to get better or improve without telling them that where they are now is a problem?
Sure. And I think some of it is the larger framing. We need to start, and this was actually honestly a bit of a struggle at Stanford, because a lot of my students at Stanford kind of got into Stanford and they're feeling like, oh my God, I can't let anyone know that I don't really know all of this already. You know, there's this
I
high.
have to prove that I belong here.
Yes, exactly. And so I would spend a big part of my class at the beginning just kind of making it okay to not know things, you know, and by even actually a good thing is being sort of vocally self-critical. It's a leadership one of the things that we do at Amazon is, you know, you need to role model that you don't know everything, and that learning things is hard. And that, you know, our brains try and be, and some people would say lazy, I say efficient. You try and just use what you already know, and it's really hard. It actually burns calories to build those new neural pathways. So it's work, it's exercise. And so it's natural tendency to kind of just think I already know something and kind of go. And so to really encourage people that where they learn is when they don't know something. So they want to be, if they know everything, if they're getting everything right to begin with, then they're not doing the right thing. You know, you have to fail and get feedback and try again. And it might take multiple times to do that. And that's good. And we did an experiment on academic mindset. I don't know if you all are familiar with Carol Dweck's work. When I was back at Stanford working with some partners in College of the Canyons Community College, we did again in introductory statistics, because that's, you know, my big area.
Right.
We did a study where we had with 20 classes, and we gave the students there were two different versions of the course. The course was essentially the same, except for the introductory material. The study strategies introductory chapter. One of them was traditional study strategies, and the other chapter was mindset intervention, where we explained to people, you know, what we know about learning being hard, and that you need a growth mindset and all that kind of stuff. And at the end of that chapter, we asked the students, we said to the students, we're actually struggling with how to communicate this research to students like you. So could you help us? Could you help us by taking some concept around this growth mindset that we just taught you about, and put it into words that you think a student like you would be able to understand? Because we're trying to figure out how to communicate this, and it would really help us if you could, you know, put it in, you know, we're a bunch of old academics, so put it in words that make sense. And so the students typed that in. Then there were 3 different places in the statistics course where we could see from the data that students really struggle, and they give up, and they don't try the hard things and stuff like that. And so at those different places in the course, in the treatment condition, we prompted the students saying, you know, this is a place in a course where students often find this concept and often find this material really hard and really struggle. But remember, and then we gave them their words back to remind them the importance of a growth or academic mindset. And then had them, and we saw students in those 3 places actually try the harder stuff more, persist longer, and learn more. So there are real strategies for helping learners start to reframe this idea of I have to know it, and if I don't do it right the first time, I failed.
That's brilliant. Thank you.
Mm-hmm.
Yeah.
Other things that help are having students like them in the future, sort of giving, you know, sort of saying how they struggled and they got through it. And it's just normalizing it is really important. Yeah.
Dr. Candice, I think we have one last question.
Okay.
Do we have time for that?
Sure. I'm fine.
Okay. Yeah. So Liv asks, can you share the outline of one of the new projects you're working on at AWS, other than the experiment you shared?
No, I can't.
Okay,
I can only share that experiment because it's been published.
okay.
At Amazon, we have a very rigorous scientific publication process. So I can only talk about the research that we're doing that has gone through that rigorous scientific publication process. That's why I shared that one.
Okay, right. And there's one more question.
But actually, I have five
Yeah,
more at the Learning at Scale conference, which is coming up in August. We have 5 more papers that are being presented there. So I guess I could talk a little bit about one of those, which I think is really cool, which is we were doing a course in interviewing skills because, Amazon hires, I don't know, like 350 people a day. And we have a very rigorous interviewing process, as I'm sure you've heard about if you look on the web, if you're trying to get a job at Amazon. But all the interviews are conducted by Amazon employees. So we don't have a special team of interviewers. Everybody interviews. So there's a skill that we need people to develop about how to interview well in order to make sure we keep the bar high on people that are hired. And also, so we have a huge diversity of interviewers. So there's a training. There used to be an all-day training that people would have to go through about how to interview at Amazon, which was a real bottleneck because, there are 800,000 people. So we created a completely online learning experience for building those interviewer skills. But of course, you don't get, if you're doing an online experience, how do you get practice? So the little innovation that we did, which was really fun, is we created an Alexa skill to be an interviewee. So you could practice interviewing by interacting with Alexa. So you ask Alexa a question. Because we have great, Alexa has great natural language processing abilities. She listens to the question. She has a set of selected responses depending on how she interprets that question. And then she responds, and then you ask your next question, and so on. And then in the online environment, we have some reflection activities that the person does to reflect on, did they get the information they needed? Essentially the learning experience part. So that's kind of a fun new little innovation. So, but that's not a generalized skill yet that's available on Alexa for everyone to use. Not yet.
Yeah, that's cool. So thank you, Candice, for this session. This was wonderful. I think all our participants, they enjoyed your session.
Great. Thanks so much.
Thank you.
And I will, I was going to type I typed my email address. Yes,
yeah,
feel free to send me email. I'm happy to engage in conversation.
Sure.
I love higher education. What can I say? And
Okay.
I appreciate all of you that are doing the good work.